Welcome to Cosmic Bedtime, a place where science drifts into dreams, and the universe whispers us to sleep. Tonight, we'll journey together through mysteries both ancient and cosmic, exploring the paradox of life, technology, and survival. So settle in, close your eyes if you wish, and let the cosmos guide you gently toward rest. Close your eyes for a moment and imagine the timeline of life on Earth stretched out before you. Not in years or centuries, but in billions of years, the incomprehensible depths of cosmic time. For the vast majority of Earth's history, our planet was home to simple forms of life, single-celled organisms floating in the oceans, silent witnesses to the turning of eons. For almost 3 billion years, evolution seemed to crawl, patient and unhurried, creating microscopic diversity but little visible drama. And then, something happened. Around 541 million years ago, in a relatively short geological window of perhaps 20 million years, the world transformed. Oceans teemed with creatures of dazzling complexity, animals with eyes that could see, limbs that could crawl, shells that could protect, and bodies that could hunt. This era, known as the Cambrian Explosion, was unlike anything before it, the sudden burst of life that laid down the foundations for nearly all modern animal groups. It was as if nature had been sketching silently in the margins for billions of years, and then, in a rush of inspiration, painted an entire gallery of wonders across the Earth's canvas. Now fast forward, skip millions of centuries, cross eras of dinosaurs and ice ages, watch continents drift and collide. Finally, land at the most recent sliver of time, mere moments compared to the deep past, the history of human civilization. Agriculture, cities, languages, and religions, all within the last 10,000 years. Writing, mathematics, and astronomy, barely 5,000 years old. The scientific method, steam engines, and electricity, only a few centuries ago. The internet, artificial intelligence, and genetic engineering, mere decades. Humanity, too, is in the midst of an explosion. But this one is not biological. It is technological. The pace of progress in the human story mirrors, in some strange and poetic way, the Cambrian Explosion. Just as life once burst into diversity and complexity, our species now experiences a sudden, almost bewildering acceleration of ideas, inventions, and innovations. What took nature hundreds of millions of years, we are compressing into decades. The paradox, the mystery, and the danger lies in whether this boom will echo the Cambrian, ushering in a new era of flourishing, or whether it risks collapsing under its own intensity, leaving behind only traces of what might have been. To understand the paradox, we must appreciate the silence before the storm. For billions of years, Earth's oceans were populated almost exclusively by single-celled life forms, cyanobacteria, algae, and other microscopic beings. They performed the slow work of transforming the atmosphere, exhaling oxygen into the air, and setting the stage for more complex life. Evolution was at work, of course, but at a pace that, from our human perspective, feels glacial. Tiny mutations, endless replications, a slow accumulation of genetic novelty. Imagine a clock ticking not in seconds, but in millennia. The vast, nearly featureless expanse of deep time lulled the planet into what seemed like eternal stillness. Then, suddenly, the clock raced forward. Multicellular organisms began to specialize, forming tissues, organs, and body plans. Creatures learned to swim, to burrow, to see, to to hunt. In evolutionary terms, it was fireworks after endless twilight. Paleontologists still debate exactly why this explosion happened. Perhaps oxygen levels rose, perhaps ecological pressures encouraged arms races, perhaps genetic innovations like Hox's genes unlocked new possibilities. But whatever the cause, the result was unmistakable, a great leap forward, a biological dawn. Now compare this to human history. For tens of thousands of years, our ancestors lived as hunter-gatherers. Tools changed little across generations. Knowledge passed orally, preserved in songs and rituals but rarely transformed. Even after agriculture began, progress was incremental: slow refinement of crops, the gradual building of towns, the cautious invention of writing. Millennia passed in relative stillness. And then, an explosion. Steam engines. Factories. Electricity. Railroads. Telephones. Airplanes. Rockets. Computers. Artificial intelligence. Each invention triggering another, accelerating the tempo of history until we live today in a world where change feels almost dizzying. What was unimaginable to your grandparents is commonplace to you. What is science fiction to you may be reality to your grandchildren. It is as though humanity, too, has reached its Cambrian moment, the sudden opening of possibilities, a boom in complexity, diversity, and power. Explosions, whether biological or technological, come with paradoxes. They represent creation but also destruction. They mark flourishing but also instability. In the Cambrian, the burst of diversity was followed by waves of extinction. Not every new body plan survived. In fact, most did not. The fossil record is filled with strange, alien creatures: Opabinia with its 5 eyes, Anomalocaris with its grasping appendages, that vanished as quickly as they appeared. The explosion gave rise to modern lineages, yes, but it also left behind evolutionary experiments that failed. So too with technology. Not every invention endures. The libraries of history are littered with forgotten devices, abandoned operating systems, dead languages of code, vanished industries. But more importantly, the explosion of technology carries risks of collapse. Weapons of mass destruction, climate change, ecological strain, artificial intelligence spiraling out of control, these are the darker shadows of our boom. Just as Cambrian predators devoured their prey, so too might our inventions consume us. The paradox, then, is whether explosions are pathways to survival or harbingers of destruction. Are they the natural pattern of progress in a universe that resists stillness? Or are they dangerous spikes in complexity that inevitably burn themselves out? Why should we compare a biological event 500 million years ago to our present-day human condition? Because in the contrast, we see patterns that transcend time. We glimpse the possibility that explosive change is not an accident, but a law, that systems, whether of life or civilization, build slowly under pressure and then erupt suddenly when thresholds are crossed. The Cambrian explosion was not just a chapter in the history of Earth, it was a turning point that made us possible. Without it, mammals and humans might never have arisen. Similarly, the technological explosion we are living through may be the turning point that determines whether humanity thrives, colonizes the stars, or perishes under the weight of its own speed. By setting the stage with this parallel, we prepare to dive deeper. In the chapters to come, we will walk through the Cambrian seas, swim alongside the strange creatures of the deep past, and then return to the modern world of silicon chips and satellites. We will ask, what drives explosions? What lessons can we learn from evolution? Can humanity navigate its own paradox? And perhaps most haunting of all, is there a cosmic rhythm to these bursts, a universal pattern that echoes across biology, technology, and maybe even alien civilizations? So as you lie back and let your mind wander, imagine two tapestries unfurling side by side. One is ancient, woven from fossils, ocean sediments, and the deep memory of Earth. The other is modern, stitched with circuits, algorithms, and skyscrapers of glass and steel. Both tell the story of explosions, of quiet preparation followed by sudden, dazzling transformation. The Cambrian explosion gave rise to us. Humanity's explosion may determine what we become. This is the paradox. This is the mystery. And this is where our journey begins. Close your eyes and picture the Earth 500 million years ago. The continents, as we know them, did not exist. Instead, strange land masses clustered together in unfamiliar shapes, barren and lifeless above the waves. The skies were blue, the oceans vast, and though oxygen had begun to fill the atmosphere, the land remained silent. No plants, no trees, no animal calls. All of life was still confined to the seas. But beneath those waves, something extraordinary was stirring. For billions of years prior, the oceans had been home mostly to microscopic organisms, bacteria, algae, and simple colonies of cells. Occasionally, larger multicellular life forms appeared, but for the most part, the story of life was quiet, repetitive, and slow. The fossil record before the Cambrian explosion reveals a sparse, almost monotonous cast of characters, soft-bodied creatures like jellyfish, sponges, and worm-like forms that left faint imprints in the rocks. Scientists call this the Ediacaran biota, a mysterious prelude to what was about to unfold. Then, around 541 million years ago, something happened. In the blink of a geological eye, just 20 to 25 million years, life exploded into diversity. Almost every major group of animals we know today made its first appearance during this period. Creatures with eyes, jaws, shells, limbs, and nervous systems emerged, transforming the oceans into theaters of predation, survival, and evolutionary innovation. This was the Cambrian explosion, evolution's Big Bang, a burst of creativity so profound that it shaped the course of life for hundreds of millions of years to come. Why did life wait so long, only to leap forward so suddenly? For decades, scientists puzzled over this question, and even today, debates continue. Several factors may have converged at once, like sparks igniting dry tinder. One hypothesis points to oxygen levels. Before the Cambrian, the atmosphere and oceans contained limited amounts of free oxygen. Many complex body structures, like shells, skeletons, and muscles, require energy that only oxygen-rich environments can sustain. As cyanobacteria and algae pumped oxygen into the seas, levels eventually reached a critical threshold. Suddenly, life could afford to spend energy on complexity. Another factor may have been genetic innovation. Around this time, organisms developed powerful new tools in their DNA, specifically, Hox genes, which act like master architects of the body. Hox's genes tell cells where to grow limbs, how to form segments, and how to arrange organs. With these genetic blueprints, evolution could experiment rapidly with new designs. Eyes, claws, fins, and antennae became possibilities that natural selection could test in the competitive arena of the oceans. Finally, the Cambrian seas themselves created the conditions for an evolutionary arms race. With predators emerging, prey needed defenses, hard shells, spikes, burrowing behaviors. Predators, in turn, evolved sharper teeth, faster swimming, and keener senses. The ecosystem spiraled into innovation, each adaptation fueling another, driving complexity ever higher. The Cambrian explosion was not just the sudden appearance of life, it was the dawn of interaction, of ecosystems filled with drama, hunting, hiding, competing, surviving. The fossil record from Cambrian deposits like the famous Burgess Shale in Canada reveals a surreal menagerie. To us, these creatures look almost alien, strange experiments in body design, many of which have no modern counterpart. Trilobites, perhaps the most iconic Cambrian animals, trilobites were armored arthropods with segmented bodies and compound eyes. They crawled across seafloors in vast numbers, some burrowing, others swimming, and they would dominate the oceans for 270 million years before extinction. Opabinia, imagine a shrimp-like creature with 5 eyes perched on stalks, and a long, flexible proboscis ending in a claw. Opabinia was bizarre even by Cambrian standards, an evolutionary experiment that never returned. Anomalocaris, often called the terror of the Cambrian seas, this predator grew up to 1 meter long, massive compared to its contemporaries. With large compound eyes and spiny grasping appendages, it hunted trilobites and other creatures, representing one of the first apex predators in Earth's history. Hallucigenia, a worm-like creature with spikes jutting from its back and delicate, clawed limbs, Hallucigenia was so strange that scientists initially reconstructed it upside down. Its name reflects its dreamlike, almost hallucinatory appearance. Waiwanocaris, Marella, and other oddities, countless other creatures from this time appear like whimsical sketches, as if nature was experimenting with every possible design. Some had bizarre spines, some transparent bodies, others forms so strange we can barely guess their lifestyle. What makes the Cambrian explosion astonishing is not just the diversity of creatures, but the diversity of body plans, fundamental blueprints for how animals are built. Nearly all the major phyla we know today, arthropods, mollusks, chordates, the group that includes us, originated in this period. In evolutionary terms, the Cambrian was the moment when the toolbox of life was filled with possibilities. Everything that followed, from dinosaurs to humans, is a remix of Cambrian designs. Among the most transformative innovations of the Cambrian was the evolution of vision. Eyes began to appear in various forms, from simple light-sensitive patches to sophisticated compound eyes. Trilobites and Anomalocaris, for example, had eyes capable of detecting movement, shapes, and even detail. Vision revolutionized ecosystems. For the first time, animals could hunt and avoid being hunted with precision. Predation became dynamic, leading to faster swimmers, harder shells, sharper teeth. But vision also implied the dawn of more complex nervous systems, capable of processing sensory information and coordinating behavior. In a sense, the Cambrian explosion was not just about bodies, it was about minds, however primitive. With eyes came awareness. With awareness came interaction. And with interaction came the tangled web of life that defines ecosystems even today. The Cambrian seas were not uniform. Continents like Gondwana and Laurentia were scattered across the globe, their shallow coastal waters providing fertile grounds for life. Warm, nutrient-rich environments nurtured blooms of algae, which fed the growing diversity of animals. Sediments preserved the remains of these creatures in exquisite detail, giving paleontologists rare windows into this ancient drama. Events like the small shelly fauna marked the gradual buildup to the explosion, tiny mineralized skeletons appearing just before the full burst. As the Cambrian progressed, reefs, burrows, and food webs all became more complex, foreshadowing the ecological sophistication we see today. Not every Cambrian experiment survived. In fact, most of the strange body plans of that era disappeared without descendants. The majority of Cambrian animals were evolutionary dead ends, prototypes that failed the test of survival. Yet a few lineages endured. Arthropods gave rise to insects, crabs, and spiders. Mollusks evolved into squids, clams, and snails. Chordates, tiny, worm-like creatures with simple backbones, eventually became fish, amphibians, reptiles, birds, and mammals. The story of the Cambrian is both a tale of abundance and a reminder of impermanence. Why does the Cambrian explosion matter to us today? Because it set the trajectory of life on Earth. Every breath you take, every movement of your limbs, every neuron firing in your brain is built on patterns established in those ancient seas. The diversity we see around us, dogs, birds, whales, humans, all traces back to the experimental burst of the Cambrian. It also offers a lesson, that long periods of stability can precede sudden, transformative change. The Earth seemed quiet for billions of years, then erupted into diversity. Perhaps human civilization follows a similar rhythm, long ages of gradual progress punctuated by rapid, explosive transformation. So when you imagine the Cambrian explosion, don't just think of it as a paleontological curiosity locked in stone. Picture it as the first great revolution of life, the spark that lit the complexity of the natural world. Imagine the oceans alive with alien creatures, bizarre shapes swimming through blue-green waters, eyes scanning, shells clashing, appendages grasping. It was the dawn of animal life. The opening act of ecosystems. The moment Earth transformed from a planet of microbes to a planet of wonders. And it is the perfect mirror for our own story, for humanity's sudden leap into technological diversity and complexity. Just as the Cambrian oceans were forever changed by that explosion, so too is our world reshaped by the boom of invention. The parallels are uncanny, and they remind us that we are part of a larger pattern, one that stretches back 500 million years and perhaps forward into futures we can barely imagine. Imagine standing in the middle of a bustling modern city at night. Neon lights glow, cars rush by, voices echo, machines hum, screens shine with endless streams of information. It feels normal, ordinary even. But pause for a moment and remember that just a few centuries ago, none of this existed. No electricity. No skyscrapers. No internet. Not even the idea of flying across oceans in hours. In the grand sweep of human history, the explosion of technology we now take for granted happened astonishingly fast. For tens of thousands of years, our ancestors lived much as their ancestors did, hunting, gathering, farming, crafting simple tools. Then, almost overnight in historical terms, came steam engines, factories, railways, telegraphs, electricity, cars, airplanes, computers, satellites, artificial intelligence. It is as if humanity itself experienced a Cambrian explosion, a sudden burst of complexity and diversity, not of bodies, but of ideas, inventions, and technologies. For most of human history, progress moved slowly. Stone tools evolved incrementally over hundreds of thousands of years. Fire was mastered. Simple shelters appeared. Later came agriculture, roughly 10,000 years ago, a profound shift, yet one that spread gradually and unevenly across the globe. The pace of change was glacial, measured in millennia. If you were transported back 5,000 years to an early farming village, life would be tough but comprehensible. Crops growing in fields, pottery for storage, bronze tools, maybe a small temple or settlement walls. Transport yourself again to 2,000 years ago, and the changes would be noticeable. Empires rising, roads, aqueducts, better weapons, written language. But still, the world would be familiar in rhythm. Horses carried people, torches lit the night, most labor was done by human or animal muscle. Contrast that with the last 300 years. A blink. A geological instant. Suddenly, the quiet hum of incremental progress erupted into a roaring symphony of invention. Historians often mark the Industrial Revolution as the spark of our technological explosion. Beginning in the 18th century in Britain, it spread across Europe, then the world. Machines powered by coal and steam transformed production, transport, and energy. For the first time, human societies could harness energy far beyond the strength of muscles, wind, or water. Factories churned out goods. Railroads stitched continents together. Telegraph lines carried messages at lightning speed compared to couriers. Cities swelled. Populations soared. The Industrial Revolution was our equivalent of oxygen rising in Cambrian seas. It unlocked the energy budget necessary to support complexity. Just as life needed oxygen to fuel shells, muscles, and nerves, society needed coal, oil, and later electricity to fuel industry, engines, and machines. From there, the explosion accelerated. In the 19th and 20th centuries, innovation cascaded like dominoes. Each new invention enabled several others, creating a feedback loop of progress. Electricity lit cities, powered factories, and transformed night into day. Medicine advanced with germ theory, vaccines, and antibiotics, doubling human lifespans. Transportation leapt from horse-drawn carriages to trains, then automobiles, then airplanes. Communication evolved from handwritten letters to telegraphs, telephones, radios, televisions, and finally, the internet. Computation began with simple mechanical calculators, then electronic computers, and now artificial intelligence capable of processing data at superhuman speeds. This rapid diversification mirrors the Cambrian seas. Suddenly, instead of a few simple tools, we had thousands, then millions, of specialized technologies. Our world became an ecosystem of inventions, each interacting with others, evolving, competing, sometimes going extinct. Think of how smartphones combine dozens of technologies, camera, GPS, radio, computing, internet, and spawn entire new industries. Much like trilobites and anomalocrids shaped Cambrian ecosystems, certain inventions dominate and reshape our technological environment. In the Cambrian, the evolution of eyes and nervous systems rewired ecosystems forever. For humanity, the parallel is the rise of information networks. Telegraphs and telephones shrank distances. Radio and television created shared cultural consciousness. The internet connected billions of minds instantly. Social media, search engines, cloud computing, these are our eyes, our collective nervous system, processing signals from across the globe in real time. Just as vision allowed Cambrian predators and prey to engage in new, complex interactions, our digital vision allows ideas, memes, and innovations to spread at lightning speed. A discovery in one part of the world can spark revolutions in another within days. The tempo of evolution has accelerated again, only this time in the realm of knowledge. The Cambrian explosion was fueled by an arms race between predator and prey. Humanity's explosion of technology is similarly driven by competition between nations, companies, and even individuals. Weapons escalate, from spears to nuclear warheads. Corporations race to dominate markets with new products. Nations compete in space exploration, computing, biotechnology. Even within society, individuals compete for attention, influence, and innovation. This arms race fuels both creativity and danger. Just as trilobites evolved shells to survive predators, we develop cybersecurity to defend against hackers. Just as anomalocrids evolved sharper claws, we designed faster processors, stronger materials, smarter algorithms. And just as the Cambrian seas were full of evolutionary dead ends, many technologies failed, forgotten gadgets, obsolete systems, extinct companies. The survivors shaped the future. If we zoom out, we can think of technologies themselves as evolving like organisms. Each invention is like a mutation, an experiment. The marketplace and society act as natural selection, rewarding useful innovations and discarding failures. The printing press, the light bulb, the airplane, these were the successful species that thrived and reproduced, spawning entire lineages of new technologies. Meanwhile, inventions like Betamax tapes or the Zeppelin were evolutionary dead ends, fascinating but unsustainable. The speed of this evolution is breathtaking. Biological evolution takes millions of years. Technological evolution happens in decades, or less. Today, software updates roll out weekly, and AI models double in capability every few months. We are living inside an evolutionary explosion visible in real time. But here lies the paradox. In the Cambrian explosion, diversity blossomed, but many forms went extinct. Likewise, in our technological explosion, progress creates both opportunities and risks. We have unleashed immense power, nuclear energy, genetic engineering, artificial intelligence. These tools can heal or harm, uplift or destroy. Just as the Cambrian explosion produced predators that reshaped ecosystems, our inventions can destabilize societies and even threaten the survival of our species. The paradox is that progress makes us more powerful, but also more vulnerable. We depend on technology for everything, from food and water systems to communication and medicine. A failure, misuse, or catastrophe could ripple through our interconnected world with devastating speed. So when we look back at the Cambrian seas, we see more than fossils. We see a mirror of ourselves. Oxygen energy sources, coal, oil, electricity. Hawk's genes, scientific methods, coding languages, modular building blocks of innovation. Eyes and nervous systems, global communication networks, the internet, AI. Predator-prey arms race, nations, corporations, and innovators locked in competition. Life exploded into new forms then. Human civilization explodes into new technologies now. Both transformations altered the course of history forever. Where does this explosion lead? In the Cambrian, life's burst of innovation set the stage for everything that followed: fish, dinosaurs, mammals, humans. In our case, the technological explosion may set the stage for futures we can scarcely imagine. Artificial intelligence becoming a co-evolver of knowledge. Biotechnology redesigning our very bodies, curing diseases, or creating new species. Space exploration extending life beyond Earth. Climate technologies deciding whether our civilization thrives or collapses. We may be living in the opening act of a much larger drama, just as the trilobites and anomalocarids were only the beginning of life's unfolding story. The Cambrian explosion was life's great leap into diversity. Humanity's explosion of technology is our leap. Both are stories of sudden complexity arising after long ages of quiet. Both remind us that transformation often comes not gradually, but in bursts. So next time you scroll through your phone, watch a rocket launch, or hear about a new AI breakthrough, imagine yourself standing in those ancient seas 500 million years ago. Strange creatures swimming, eyes scanning, shells clashing. Life learning to see, to move, to compete. Now, the oceans are gone, but the pattern repeats. We are the trilobites, the anomalocarids, the hallucigenias of our time, creatures in the midst of an explosion, living through history's great burst of invention. And just like the Cambrian, what survives from this boom will shape the future of Earth, for millennia, perhaps millions of years to come. Why do explosions happen? Not the destructive kind we see in movies, but the creative bursts that reshape history, the Cambrian explosion of life, the industrial and technological explosions of humanity. Why is it that for millions of years, life remained simple, then suddenly bloomed into shells and eyes? Why did humans live for millennia with stone tools, only to leap within a few centuries to spacecraft and artificial intelligence? The answer is rarely a single cause. Explosions of complexity are not sparks from nothing, they are threshold events, triggered when conditions finally align. Long periods of quiet accumulation build the stage. Then, once certain factors reach a critical level, change cascades rapidly. It is like water slowly heating in a pot, nothing seems to happen, until suddenly it boils. In both biology and civilization, explosions are driven by enablers, resources, mechanisms, and environments that allow complexity to flourish. Let us explore what drove life's great burst in the Cambrian, and what drives humanity's own explosion of technology today. For hundreds of millions of years before the Cambrian, Earth was already home to life. Microbes thrived, algae carpeted shallow seas, simple multicellular organisms drifted like jelly in the oceans. But complexity was capped. The world was not yet ready for an explosion. Three key factors changed that. 1. Oxygen, the energy budget of complexity. Just as fire cannot burn without fuel, complex life cannot survive without abundant energy. Before the Cambrian, oxygen levels were low. Simple microbes could make do, but larger, more active animals could not. Then oxygen rose, likely due to massive blooms of photosynthetic algae and cyanobacteria. By the time of the Cambrian, oxygen had reached levels high enough to sustain active metabolisms, muscles, and new tissue types. Predators could chase prey. Prey could evolve defenses. Energy abundance opened the door to ecological arms races. Without oxygen, trilobites' shells would have been impossible. With it, the seas filled with armored creatures, fast swimmers, and keen-eyed hunters. 2. Hawke's genes, the blueprint of innovation. Oxygen provided energy, but organisms also needed instructions, genetic tools to build new body forms. Enter Hawke's genes, master regulators of body development. Hawke's genes act like an architectural toolkit. Instead of reinventing how to make each organ from scratch, organisms could shuffle and repurpose genetic modules, appendages here, eyes there, shells wrapping around. This modularity accelerated innovation. With Hawke's genes, evolution could experiment quickly, trying new body plans with relatively small genetic changes. Many of those experiments, like trilobites' segmented armor or anomalocarid's grasping claws, were spectacular successes. Without the blueprint, oxygen alone would have produced little more than larger blobs of jelly. With the blueprint, the ocean filled with design diversity. 3. Environmental stability, a stage for growth. Finally, the environment itself became more stable. Earlier Earth had endured dramatic swings, snowball Earth glaciations, massive volcanism, unstable climates. By the Cambrian, conditions had calmed. Stable seas allowed ecosystems to build complexity without being reset by catastrophe every few million years. Stability is the silent partner of innovation. Chaos may spark novelty, but sustained growth requires a steady stage. Together, oxygen, genetic toolkits, and environmental stability, these factors pushed life past a critical threshold. Suddenly, the quiet seas burst into ecosystems teeming with predators, prey, and unprecedented forms. Now fast forward 500 million years. Humanity's own explosion of tools, machines, and knowledge rests on parallel drivers. 1. Energy, our oxygen equivalent. Every leap in human technology has followed a leap in energy capture. Fire allowed early humans to cook food, freeing more calories for brain growth. Agriculture concentrated solar energy in grains, supporting cities and specialization. Fossil fuels, coal, then oil, then natural gas, unleashed orders of magnitude more energy, powering factories, transport, and entire industrial societies. Electricity distributed energy flexibly, transforming night into day and powering countless inventions. Energy abundance is civilization's oxygen. It allows more people, more machines, more experiments. Without cheap energy, there is no industrial boom, no digital age. 2. Information, humanity's Hawke's genes. Just as Hawke's genes gave evolution a modular blueprint, information systems gave humanity a toolkit for invention. Language enabled collective memory and oral traditions. Writing allowed knowledge to be stored and transmitted across generations. Printing democratized access to ideas, fueling revolutions in science and politics. The Internet created a planetary nervous system, accelerating innovation beyond anything seen before. Information is humanity's genetic code, not written in DNA, but in books, data, and digital archives. It allows us to recombine old ideas into new forms, much like evolution recombined Hawk's modules into endless body plans. 3. Social cooperation, our stable environment. No invention thrives in isolation. Human cooperation, through trade, governance, culture, and shared norms, creates the stability necessary for innovation to compound. Consider, tools spread because communities taught them. Agriculture flourished because societies organized around surplus. Industrialization spread because nations built infrastructure and markets. Even today, international standards, scientific collaboration, and global supply chains act as the stable seas where technological organisms evolve. Without social cooperation, discoveries remain isolated sparks, extinguished before they can ignite revolutions. The Cambrian Explosion and the human technology explosion share a profound pattern: gradual buildup, sudden burst. For eons, oxygen rose slowly before hitting the tipping point. Genetic innovations accumulated invisibly before Hawk's genes unlocked rapid diversity. Environmental swings calmed only gradually, until finally ecosystems stabilized. Similarly, humans invented fire, language, agriculture, and writing over millennia. Each was powerful, but not yet explosive. Only when energy, fossil fuels, information, printing and science, and cooperation, social and political systems, aligned did the explosion ignite. This is the concept of the critical threshold. Complex systems do not evolve smoothly, they hold steady until conditions align. Then, like water boiling, change cascades. Below the threshold, progress is incremental, fragile, easily reversed. At the threshold, forces converge, and exponential growth begins. Beyond the threshold, the system transforms irreversibly, creating new possibilities and risks. One of the paradoxes of explosions is that they feel sudden to those living through them, but in hindsight, we can see the long preparation. To Cambrian organisms, the seas must have seemed to erupt with predators overnight. To 18th century farmers, the sudden appearance of steam engines, factories, and railroads must have felt just as shocking. Yet neither was truly instantaneous. Both were the result of slow, unseen accumulation. Oxygen molecules, genetic toolkits, tiny social inventions, all building silently, until the tipping point arrived. Explosions are long in preparation, short in execution. The pattern of buildup and threshold explosion is not limited to biology or technology. We see it across nature and society. Stars ignite only when hydrogen density and temperature cross a threshold. Volcanoes erupt after magma pressure silently builds. Markets boom when innovations, capital, and demand converge. Ideas spread like wildfire once social networks reach critical connectivity. Thresholds are everywhere. They are the gates through which history lurches forward. If explosions are driven by thresholds, the pressing question is, what thresholds lie ahead for humanity? Artificial intelligence. When algorithms cross a threshold of capability, entire industries may be transformed, much like ice transformed Cambrian seas. Biotechnology. CRISPR and genetic engineering may unlock new blueprints for life, parallel to Hawk's genes. Energy. Fusion power, if realized, could provide nearly limitless energy, an oxygen surge for civilization. Social cooperation. Global governance on climate, pandemics, and AI safety could stabilize our environment for sustainable growth, or its absence could trigger collapse. We may be standing at the edge of another explosion, one whose shape we cannot yet see. Explosions, whether of life or technology, are not random. They are the inevitable result of conditions aligning, thresholds being crossed. Oxygen, genes, and stable seas gave us the Cambrian burst of animal diversity. Energy, information, and cooperation gave us the human burst of technological innovation. To understand explosions is to understand ourselves. We are not living in an age of ordinary change, but in the aftermath of thresholds crossed. And perhaps on the brink of new ones. When the water boils, it does not matter whether we were watching the pot, it erupts all the same. Our task is to see the thresholds approaching, to prepare, and to guide the explosion toward creation rather than destruction. Because in the story of Earth, explosions are the moments that matter most. The Cambrian explosion is often celebrated as the dazzling dawn of complex life on Earth, a moment when the evolutionary stage suddenly filled with strange, fascinating creatures. Trilobites crawled across the ocean floor, anomalocaridids glided through the water with menacing grace, and spiny, alien-like worms burrowed in the mud. It was a riot of diversity, a burst of evolutionary creativity unparalleled in Earth's history. But woven into this triumphant story is a quieter, darker truth. Most of those extraordinary Cambrian species are gone. They did not survive. The paradox of the Cambrian explosion is that its brilliance was fleeting. Bursts of innovation do not guarantee permanence. Indeed, the very forces that drive explosive growth often set the stage for collapse. And so, as we look to humanity's own explosion of technology, our exponential leap from fire and stone tools to quantum computers, rockets, and artificial intelligence, we are forced to ask a sobering question: could our boom lead us, too, toward extinction? The fossil record tells us that more than 80% of Cambrian lineages disappeared. Many of the creatures that once ruled the oceans are little more than ghostly impressions in shale beds today. They thrived briefly, then vanished, victims of evolutionary pressures they could not withstand. The trilobites, for instance, survived for hundreds of millions of years but ultimately succumbed to changing seas and competition. Other Cambrian oddities, like Hallucigenia, with its spiky back and stubby legs, were evolutionary experiments that failed the test of time. Why did so many perish? The answer lies in the brutal logic of natural selection. Once the ecological niches filled, competition intensified. Some species adapted, others could not. Survival was not guaranteed to the most bizarre or even the most complex, but to those best suited to shifting conditions. This is the paradox of survival. Explosive innovation expands diversity but also sharpens the knife of extinction. Every new success creates pressure on the ecosystem, forcing others out. If we hold up the Cambrian explosion as a mirror, humanity stares back at itself uneasily. Our technological boom has unleashed a flood of inventions: nuclear power, biotechnology, artificial intelligence, global communication systems, that reshape our world at dizzying speed. Each invention is a triumph of ingenuity, but each also carries seeds of risk. Nuclear energy gives us both electricity and weapons of mass destruction. Biotechnology opens doors to curing diseases and also to engineering pandemics. Artificial intelligence can assist us in solving global problems, yet it can also destabilize economies, spread disinformation, and perhaps someday outgrow our control. Like the Cambrian Sea filled with creatures competing for survival, our modern world is crowded with technology struggling for dominance. Some will persist and shape our future. Others will be cast aside. But the most unsettling possibility is that one or more of these technologies could become the equivalent of an evolutionary dead end, not just for a single invention, but for humanity itself. The concept of survival of the fittest is often misunderstood as meaning the strongest always win. In truth, fitness means adaptability. Those organisms best suited to their environment, not necessarily the fiercest, survive and pass on their traits. The same can be said of technology. Consider VHS and Betamax, or the rise of smartphones over earlier communication devices. The fittest technologies are not always the most advanced, but the ones that fit human needs, market forces, and social systems. Yet when we extend this analogy further, a chilling thought emerges. Just as Cambrian life was pruned by environmental changes and competition, so too could humanity be pruned by the very technologies we've unleashed. Survival of the fittest, in this context, might not mean the survival of humankind, but of whichever system, biological or artificial, proves more adaptable in the long run. Could AI someday become the fittest species on Earth, leaving us behind as evolutionary relics? Could biotechnology create organisms that outcompete natural life? The Cambrian record reminds us that explosions are not forever, they are phases of testing, filtering, and elimination. Every explosion carries within it the possibility of collapse. The Cambrian explosion created dazzling diversity, but much of it was unsustainable. In evolutionary terms, collapses are not accidents, they are natural outcomes of overshoot. Human history has its own echoes of this cycle. Civilizations rise, innovate, and flourish, only to fall when their systems outpace their ability to sustain them. The Maya built great cities but collapsed under drought and resource strain. The Roman Empire stretched too far and eventually fractured. The Industrial Revolution gave us unprecedented power but also pollution, inequality, and climate change. Our current technological explosion may be following a similar trajectory. We are innovating faster than we are regulating, creating tools before we fully understand their consequences. Collapse, in this context, might not mean total extinction but could mean a drastic pruning of human population, culture, or capability. This is the paradox again. The same forces that make us strong could make us fragile. What can we learn from creatures that lived more than 500 million years ago? Their world may seem distant, but the lessons are timeless. 1. Innovation is not immunity. No matter how advanced a species, or a civilization, becomes, it is still vulnerable to external pressures and internal flaws. 2. Diversity is protection. The Cambrian seas were filled with life forms, and while many perished, Others adapted and became the ancestors of today's animals. Humanity, too, may need diverse approaches to technology, governance, and culture to avoid collapse. 3. Resilience matters more than speed. The Cambrian burst was dazzling but short-lived in evolutionary terms. Long-term survival requires resilience, the ability to endure shocks and changes. If we apply these lessons, we may see that our goal is not to stop innovation, but to ensure it does not outpace our capacity for resilience. Imagine standing on the shoreline of a Cambrian ocean, watching creatures swarm in sudden abundance. The water is alive with strange beauty, but you know that most of these species will not last. That is the knife's edge of survival. Now imagine looking at our modern world, satellites glittering in orbit, data streaming through invisible networks, cities glowing at night. It is just as dazzling, just as full of vitality and promise. And yet, we too are on a knife's edge. The paradox of survival is not simply a lesson from the past, it is our present reality. The Cambrian Explosion teaches us that bursts of innovation are both opportunities and dangers. They bring creation, but also destruction. They give us a future, but only if we navigate carefully. Will humanity survive its own explosion? That question may define our century. If we manage to adapt, balancing innovation with wisdom, speed with resilience, our boom could echo not as a brief flash, but as the beginning of a new era. But if we fail, if we allow our technologies to grow unchecked, to fracture our societies or overwhelm our planet, then we may end up like so many Cambrian species, brilliant for a moment, forgotten in the deep time of Earth. Perhaps this is the true paradox: survival is not guaranteed, even to the most creative and advanced. The test is ongoing, and the outcome is still unwritten. The Cambrian Explosion is remembered not only for the sudden burst of new life but also for the complexity of those creatures. Before it, Earth's oceans were mostly home to simple organisms, sponges, jellyfish-like creatures, tiny worms. After it, animals developed exoskeletons, eyes, gills, digestive tracts, and segmented bodies. Complexity was not gradual, it leapt forward. Humanity's technological story mirrors this trajectory. Just a few thousand years ago, our tools were stone axes and fire. Today, we build global supply chains, interconnected AI systems, and machines capable of modeling the origins of the universe. Complexity has skyrocketed, and with it, both possibility and peril. This part explores what complexity means, why it is both a gift and a burden, why it arises in bursts, and what costs humanity must bear for pursuing it. The Cambrian Explosion is sometimes described as evolution's Big Bang. One reason is that organisms developed far more intricate designs in a very short period. Eyes emerged, granting vision in a world that had largely been blind. Suddenly, predators and prey entered an evolutionary arms race. Skeletons and shells formed, giving structure and protection, but also demanding more energy to build. Circulatory and nervous systems expanded, enabling faster movement, coordination, and sensing. Each innovation raised the stakes. Vision, for instance, made hiding harder, which pressured other creatures to evolve camouflage, spines, or mobility. Skeletons enabled strength but also added fragility. If they failed, death was certain. Complexity is never free. Every new organ, structure, or behavior requires energy, regulation, and maintenance. The Cambrian seas show us how quickly life ran toward this complexity, and how many species stumbled along the way. Our own explosion of technology is characterized by a similar escalation. Consider the following. Artificial intelligence. We now create machines that learn patterns faster than we do, but their decision-making processes are often opaque. AI doesn't just execute instructions, it evolves behaviors inside vast networks that even its creators struggle to understand. Global systems, the food you eat, the phone in your pocket, the electricity powering your home all depend on sprawling international supply chains and interdependent infrastructures. No single person comprehends the entire web. Digital networks. Billions of devices communicate across satellites, servers, and cables, creating a planetary nervous system. This network enables instant communication, but it also spreads misinformation, cyber attacks, and systemic vulnerabilities. Like Cambrian organisms, we build structures that make us more capable but also more fragile. When a global financial network hiccups, it can cascade into recession. When a supply chain breaks, millions may go hungry. When AI behaves unpredictably, it can amplify risks beyond our control. Our species thrives on complexity, but we are also ensnared by it. Why does evolution, or civilization, rush toward complexity? 1. Arms races. In nature, once one creature develops eyes, others must adapt to survive. In technology, once one nation develops advanced weapons or AI, others must keep pace. Complexity snowballs. 2. Energy access. Cambrian life likely flourished because oxygen levels rose, making it possible to sustain energy-hungry structures like muscles and brains. Humanity, too, has tapped vast new energy sources, fossil fuels, electricity, nuclear power, that allow us to sustain energy-hungry technologies. 3. Information and memory. Genes encode instructions for life. Once more sophisticated genetic toolkits like Hox's genes emerged, organisms could develop modular, reusable parts. Humanity has its equivalent in language, writing, and digital storage, which let us preserve and build on knowledge. Complexity is attractive because it opens new possibilities. A creature with eyes can hunt more efficiently. A society with the internet can coordinate globally. But complexity is also a trap. The higher it climbs, the harder the fall when it fails. The Cambrian explosion was dazzling, but its complexity came at a cost. Many creatures invested heavily in new traits only to find those traits unsustainable. A predator with elaborate sensory organs but insufficient prey would collapse. A shelled creature that required too much calcium in a changing ocean might perish. Humanity faces parallel risks. Fragility of interconnection. Our systems are tightly coupled. A disruption in one node can ripple globally. A single cyber attack, pandemic, or supply chain disruption can grind entire sectors to a halt. Unintended consequences. The more intricate a system, the harder it is to predict. AI decisions, climate models, and economic dynamics often surprise even experts. Complexity generates black swans. Maintenance costs. Every layer of innovation requires upkeep. Power grids, internet cables, satellites, roads, data centers, all demand constant energy and resources. As infrastructure grows, so do the costs of sustaining it. In essence, complexity can consume the very resources it unlocks. Cambrian creatures burn through oxygen, humanity burns through fossil fuels and minerals. Both risk collapse if growth outpaces sustainability. Complexity is not inherently good or bad. It is a double-edged sword. Strength: complex systems can solve problems simple ones cannot. Human brains, with billions of neurons, can imagine futures, plan, and create art. AI, with trillions of parameters, can recognize patterns invisible to us. Weakness: complex systems are harder to repair. If a simple organism loses a cell, it may survive. If a complex system loses a critical organ, or a critical infrastructure hub, the whole collapses. The paradox is that complexity makes us more capable and more vulnerable simultaneously. It gives us power but demands balance. Nature's experiments during the Cambrian Explosion offer insights. Redundancy matters. Some creatures developed multiple sensory systems or backup strategies. Similarly, our systems may need redundancies, multiple energy sources, diverse food supplies, backup communication networks. Modularity aids survival. Creatures with segmented bodies, like arthropods, could lose parts without dying. Our technologies might emulate this, building modular, decentralized systems that can absorb shocks. Simplicity endures. Many of today's species, like jellyfish or bacteria, are simple yet highly resilient. Sometimes survival favors simplicity over brilliance. Perhaps the lesson is not to abandon complexity, but to temper it with resilience, diversity, and humility. Both biology and society seem to follow a pattern. Complexity increases until a threshold is reached. Beyond this, the system either stabilizes into a sustainable form, or collapses. The Cambrian Explosion reached such thresholds. Some lineages stabilized, giving rise to enduring body plans. Others crossed thresholds they could not sustain and disappeared. Humanity is rushing toward its own threshold. With AI, biotechnology, and global networks, our systems may soon surpass our ability to comprehend them. When complexity outpaces oversight, collapse looms. This is why some thinkers speak of a singularity, a point where complexity accelerates beyond human control. Whether that leads to transcendence or disaster depends on how we manage the costs. The Cambrian Explosion did not end life, it transformed it. Out of the chaos and collapse, enduring lineages arose, including those that eventually led to us. Complexity pruned itself, leaving only what worked. Our technological explosion may follow a similar path. Some systems will fail, others will stabilize. Humanity's challenge is to guide this process consciously, to avoid being among the evolutionary casualties of our own inventions. We must ask, how much complexity is too much? Can we design systems that remain comprehensible and resilient? Do we need to embrace simplicity in certain areas to ensure survival? If we fail to answer, we may find ourselves as fragile as a Cambrian creature, brilliant for a moment but unsustainable in the long run. The Cambrian Explosion shows us the allure of complexity, dazzling, rapid, transformative. It also shows us its price: fragility, collapse, extinction. Our species is now writing its own Cambrian chapter, building technologies that interlace across the planet. Complexity is our gift, but also our burden. To survive, we must learn not only to innovate, but to simplify, stabilize, and sustain. Perhaps the final lesson is this: complexity is not destiny. It is a choice, and with it comes responsibility. If we can balance power with wisdom, our explosion will not echo as a brief flash in history, but as the beginning of something enduring. When paleontologists study the Cambrian Explosion, they don't just marvel at the strange forms of trilobites, anomalocaridids, or early chordates. They also ask why some innovations thrived while others vanished. Evolution is not a smooth march forward, it is a chaotic process of experiments, failures, and rare successes. Technology, too, evolves. Though we like to believe every invention represents progress, history shows otherwise. Some technologies flourish and reshape societies, others disappear into obscurity, outcompete, abandoned, or simply forgotten. Biology and technology share a principle: not all that bursts into existence will endure. Life during the Cambrian explosion was marked by breathtaking variety. Fossils reveal creatures with bizarre anatomies: five-eyed predators, armored worms, spined filter feeders, that seem almost alien. Yet the vast majority of these lineages left no descendants. Why? Evolution is a brutal filter. Selective pressures, traits must prove useful in a changing environment. Eyes revolutionize survival, unnecessary armor often weighed animals down. Energy efficiency, complex features required energy. Those that consumed too much without delivering proportional benefit disappeared. Ecological niches, only certain strategies fit the available roles in ecosystems. Not every innovation had a place to thrive. Thus, while the Cambrian explosion birthed thousands of experiments, only a handful formed the enduring, body plans that still dominate Earth today: arthropods, chordates, mollusks. This is the first lesson: evolution celebrates novelty, but it remembers only resilience. Human innovation resembles biological evolution in surprising ways. We create technologies at a furious pace: printing presses, steam engines, nuclear reactors, cryptocurrencies, artificial intelligence. But not every innovation survives. Obsolete technologies, Betamax tapes, floppy disks, VHS players, all once revolutionary, now discarded. Failed experiments, many inventions never found users, like pneumatic tube transport or early VR headsets in the 1990s. Overtaken by rivals, social media platforms rise and fall, programming languages compete, energy technologies fight for dominance. Just as natural selection prunes biology, market forces, cultural adoption, and ecological constraints prune technology. The Cambrian teaches us, innovation alone is not enough. It must fit an environment, an economy, a society, a planet's finite resources. Though parallels exist, biological evolution and technological evolution differ in important ways. Natural selection. Blind, unguided, without foresight. Driven by random mutation and environmental pressures. Survivors reproduce, losers vanish. Technological selection. Guided, at least partially, by human intent. Driven by design, markets, politics, and values. Survivors are those adopted, funded, and maintained by societies. Yet, even though technology is guided, it often behaves unpredictably. The creators of social media never foresaw its global psychological impact. The inventors of fossil fuel engines didn't anticipate climate change. Once released, technologies mutate, repurposed, hacked, misused, in ways their designers cannot control. Thus, technological selection still contains an echo of Darwin's blind process. We plant seeds, but the environment decides which will grow. The Cambrian record warns us against assuming every burst of innovation leads to permanent advancement. Many Cambrian creatures were extraordinary, but they were evolutionary dead ends. Our own era is full of dazzling experiments, AI-generated art, blockchain systems, fusion research, neural implants. Some may transform civilization, others may vanish in a decade. The danger lies in mistaking novelty for inevitability. Just because something is invented does not mean it will persist. Google Glass seemed like the future of wearable computing but failed to find its niche. Concorde jets promised supersonic travel, but high costs and inefficiency grounded them. Nuclear power offered limitless energy, but political, economic, and ecological constraints slowed its adoption. Like Cambrian organisms, many technologies shine briefly and disappear, leaving fossils in history's archives. In biology, fitness does not mean strength or intelligence. It means adaptiveness, the match between an organism and its environment. A cockroach, for example, is fitter than a tiger in many contexts, because it reproduces quickly and survives diverse conditions. For technology, fitness also means fit to context. Economic fitness, is it affordable and scalable? Social fitness, does it align with cultural values and behaviors? Ecological fitness, can it be sustained without destroying the resources it depends on? Political fitness, does it fit within power structures, or does it threaten them? A technology may be brilliant but unfit. Consider Nikola Tesla's wireless energy transmission, visionary, but economically unfit in a world driven by profit. Conversely, the humble shipping container, cheap, simple, standardized, reshaped global trade because it was supremely fit. The lesson is sobering. Survival does not always reward the best idea, but the most adaptable one. Extinction is not confined to biology. Technologies, like species, can disappear when they are too specialized. Cambrian predators that depended on one food source vanished when prey changed. Similarly, technologies built on narrow conditions, like fax machines, become obsolete when environments shift. They are outcompete, just as trilobites will eventually outcompete, technologies lose out to more efficient rivals. They collapse under their own weight. Complex Cambrian species sometimes invested too much in costly structures. Today, systems that demand excessive infrastructure, e.g., sprawling data-heavy platforms, may fail if resources dwindle. Extinction is not failure, it is part of the evolutionary cycle. But ignoring it leaves us vulnerable. From the Cambrian, we learn 1. Diversity first, survival later. Explosions of innovation produce a dazzling variety. But only a fraction survive long-term. Our current digital explosion will likewise narrow down to a few enduring technologies. 2. Adaptation beats perfection. the most elegant creatures of the Cambrian often vanished. The humble and adaptable persisted. We should not confuse technical brilliance with inevitability. 3. Resilience over novelty. In nature, endurance matters more than sudden brilliance. Technologies must be judged by resilience, energy use, sustainability, societal fit, not just novelty. 4. The filter of environment. Just as ecosystems shape survival, so too do economies, cultures, and ecologies shape technology. If climate, politics, or values shift, many innovations will not pass the filter. These lessons remind us, innovation is not destiny, but an audition. Unlike nature, we are not entirely at the mercy of blind selection. Humanity has agency. We can choose which technologies to support, regulate, and abandon. We can reward resilience over hype. But this requires foresight, something evolution lacks. Will we use it? Or will we let short-term markets and political rivalries dictate survival, as blind and unforgiving as natural selection? The Cambrian explosion ended with mass extinctions, but its survivors shaped all future life. Our technological explosion may follow the same path, a great pruning, where only certain technologies endure. The question is whether we will guide the pruning, or be pruned ourselves. The Cambrian explosion shows us both the thrill and the tragedy of innovation. Most experiments failed. Only a few became the roots of enduring lineages. Technology mirrors this. We live in a time of dazzling invention, but not all of it will survive. Some ideas will fossilize in history's archives, while others will seed the future. The lesson from evolution is clear: resilience, adaptability, and fit matter more than novelty. If humanity wants its technologies, and itself, to endure, it must learn to think like evolution, to prune, adapt, and survive. The Cambrian seas whisper across 500 million years, burst forth, but remember, only the enduring will remain. 500 million years ago, the Cambrian explosion marked a threshold in the history of life. For billions of years, Earth's oceans were home to simple, almost invisible organisms, single cells, algae, tiny colonies. Then, suddenly, the quiet turned into a riot of complexity. Eyes appeared. Predators hunted. Ecosystems flourished. Life passed through a doorway it could never retreat from. Today, humanity may be approaching a similar threshold. But ours is not biological, it is technological and civilizational. The question is stark: are we standing at the edge of our own Cambrian moment, a transition that could launch us into a new cosmic chapter, or one that could consume us before we cross? The Cambrian explosion was not just about diversity, it was about irreversibility. Once complex body plans and nervous systems emerged, the world could never go back to the age of simple microbes. Similarly, the technological burst of the 21st century, biotechnology, nanotechnology, renewable energy, space exploration, is driving us toward a point of no return. Artificial intelligence is already demonstrating abilities once thought exclusive to human minds: learning, creating, strategizing. Genetic engineering gives us the power to redesign life, including ourselves. Space technology hints at interplanetary and interstellar futures. Quantum computing and networks may restructure the fabric of communication and discovery. Each of these is like the invention of eyes in the Cambrian, opening new evolutionary possibilities, but also new vulnerabilities. If life had a Cambrian threshold, humanity now stands at its technological threshold. Perhaps the clearest mirror of the Cambrian in our time is artificial intelligence. In biology, once nervous systems emerged, organisms could adapt faster than genes alone allowed. Learning, memory, and coordination accelerated evolution. Predators and prey began an arms race that shaped the planet. AI may be our equivalent of nervous systems. Already, AIs can rewrite code, optimize themselves, generate knowledge faster than humans can comprehend. The leap from AI designed by humans to AI designing itself is small on the evolutionary scale. Once that happens, the acceleration could dwarf all past innovation. This is the AI Cambrian Explosion scenario, millions of algorithmic experiments spawning daily, competing, mutating, outpacing human oversight. But evolution is brutal. Many Cambrian creatures vanished. Will humanity survive its own creations, or become like trilobites, once dominant, now only fossils? Another possibility at the threshold is spacefaring civilization. In the Cambrian, new body plans allowed animals to explore new ecological niches, burrowing, swimming, hunting. In our age, technology is our body plan, and space is our new niche. Rockets are becoming reusable. Plans for Mars colonization multiply. Telescopes reveal habitable exoplanets. Propulsion concepts, fusion drives, solar sails, antimatter, are shifting from speculation to engineering. Crossing into interstellar space would be the ultimate Cambrian leap. Just as life once expanded from microbial mats to predators and reefs, humanity could expand from earthbound society to cosmic civilization. But here, too, lies danger. A species unready for such power may scatter itself into extinction before it stabilizes. The Cambrian taught us, exploration creates both opportunity and risk. Some species thrived in new niches, others perished in the attempt. The Cambrian explosion was fast in geological terms, 20 million years of furious innovation. But life had the luxury of time. If one experiment failed, others continued. Humanity does not have such luxury. Our explosion is compressed into decades, not millennia. The speed itself is dangerous. AI capabilities double yearly. Genetic engineering breakthroughs arrive monthly. Global interconnectivity spreads technology overnight. A single misstep, an engineered virus, an uncontrolled AI system, a destabilizing climate tipping point, could end the story before it begins. Thus, the threshold is not only about what technologies emerge, but how fast we let them emerge. The ability to accelerate must be balanced with the wisdom to control. Evolution has no control, it is blind. But humanity is not bound by that blindness. We can choose to regulate AI development, setting safety guardrails, to pace genetic modification, ensuring ethical clarity, to govern space expansion, avoiding uncontrolled competition, to weigh ecological sustainability against short-term gain. The paradox is this: control slows us down, but survival may require slowness. A reckless sprint through the threshold could mean extinction, a measured walk could mean endurance. This is unlike the Cambrian, where life had no foresight. Humanity is unique. We can look forward and decide whether we want to accelerate or restrain. The question is whether we will use that foresight, or whether political and economic rivalries will push us into blind acceleration. Every threshold is also a cliff. To cross it safely, one must balance curiosity with caution. The Cambrian explosion birthed predators, but also mass extinctions. Our technological explosion births AI and spaceflight, but also existential risks. The line between breakthrough and catastrophe is razor thin. An AI arms race could bring self-destruction before self-evolution. Space colonization could drain Earth before it secures survival. Genetic engineering could cure diseases or create them. Thus, the threshold is not just opportunity, it is danger amplified. Are we at the dawn of a cosmic Cambrian, or at the edge of self-destruction? The answer depends not on the technologies themselves, but on how we govern their unfolding. The Cambrian explosion was inevitable once conditions were set. But humanity's threshold is not inevitable, it is a choice. We must ask: do we value wisdom as much as discovery? Will we pace our innovations to align with our capacity to control them? Can we act as custodians of evolution, not just catalysts of chaos? If the answer is yes, our threshold may open into the universe itself. If not, we may leave behind nothing but digital and fossil traces of an intelligence that burned too bright, too fast. The Cambrian explosion reshaped life forever. Humanity now stands on a parallel edge, a technological Cambrian that could expand intelligence across the stars. AI self-evolution could be our nervous system. Interstellar travel could be our new ecological niche. But unchecked speed could be our extinction. The threshold is real, and we are standing upon it. The seas of possibility stretch before us, vast and unknown. From the Cambrian, a whisper returns across deep time. The burst of life is a gift, but only those who endure will inherit the future. The Cambrian explosion was not just a chapter in Earth's story. It may have been a chapter in a cosmic pattern. For billions of years, the universe has been silent, or so it seems. Stars are born, planets spin, galaxies swirl. Yet, when we listen for voices from beyond, we hear only emptiness. Where is everyone? Perhaps the answer lies in a universal law: civilizations, like species, must pass through their own Cambrian moments, bursts of innovation so rapid and transformative that survival is uncertain. On Earth, the Cambrian explosion was a threshold. Conditions aligned, oxygen levels rose, genetic toolkits matured, ecological niches opened, and suddenly, the biosphere surged into complexity. Could civilizations elsewhere face the same structure? For eons, a planet may host simple life: microbes, photosynthesizers, algae. Then, at some unpredictable point, intelligence emerges, and with it, the tools of rapid transformation. Fire, metallurgy, agriculture, electricity, computation. The leap from stone tools to spacecraft may take only a few thousand years, a blink compared to the billions before. Once intelligence ignites, the pace becomes explosive, and the window between simplicity and godlike power becomes dangerously narrow. The Cambrian template may thus be universal: long stagnation, sudden explosion, followed by a question of survival. This brings us to the Great Filter, one of the most haunting concepts in astrobiology. Proposed by economist Robin Hanson, the Great Filter is an explanation for the Fermi paradox: if intelligent life can arise, and if the universe is vast and old, then where are the civilizations? Why don't we see them in our telescopes, or hear them in our radios? The Great Filter suggests that somewhere along the path from chemistry to interstellar civilization, there is a near impossible step, a filter that almost no species passes. But where is it? If the filter lies behind us, then we are lucky beyond comprehension. Perhaps abiogenesis, the origin of life, is astronomically rare. Or maybe multicellularity, or intelligence itself, almost never occurs. In this case, humanity may be unique, or nearly so. If the filter lies ahead, then our Cambrian moment is perilous. Perhaps most civilizations self-destruct when they invent nuclear weapons, superintelligent AI, or planetary-scale technologies. In this case, we are not lucky survivors, we are fragile candidates, likely to fail as others did. The Cambrian Explosion teaches us that once conditions align, innovation is unstoppable. But unstoppable does not mean survivable. The Great Filter may simply be the tendency of explosive innovation to outpace the ability to manage it. What if the Cambrian pattern is not a one-time event, but part of a repeating cycle? On Earth, complexity surged, crashed, and surged again. After the Cambrian came mass extinctions. After dinosaurs, mammals rose. Innovation is not linear, it pulses. Civilizations may follow the same rhythm. They rise explosively, collapse under the weight of their own technology or environment, and then, if they leave seeds, something new rises. A species may self-destruct but leave behind durable machines. An AI may inherit a world after biological collapse. Colonies may outlive their home planet's fall. In this way, the universe may not be silent, it may be filled with the ruins of Cambrian moments, civilizations caught between the spark of intelligence and the challenge of endurance. Perhaps we have not detected them because the cycle is young, and we are among the first. Or perhaps because ruins do not shine like empires. If there is a cosmic Cambrian, where are we within it? By all evidence, humanity is at the earliest phase of its explosion. Our AI is embryonic, compared to what it could become. Our spaceflight is primitive, limited to the moon and robotic scouts. Our planetary management is clumsy, as climate instability reminds us. We are still fragile, still untested. The critical question is whether we will become one of the many failed experiments, or one of the rare survivors that push past the filter. The Cambrian analogy is sobering. Most new lineages of that era vanished. Only a few persisted, shaping all future life. The same may be true of civilizations. Why is the universe silent? Perhaps because survival is the exception, not the rule. Imagine billions of planets where intelligence arose, only to collapse in its own Cambrian fever. Nuclear war, ecological collapse, uncontrolled AI, or resource exhaustion, each a plausible filter. The survivors, if any, may be rare and hidden. Some may deliberately avoid broadcasting, wary of predators. Others may evolve into forms beyond recognition, machine intelligences living in black hole computers, invisible to our telescopes. Thus, the silence may not mean we are alone, but that most voices do not last long enough to be heard. What if even survival is not the end, but a step in a larger cycle? Just as life did not stop with the Cambrian, civilizations may not stop with passing the Great Filter. A species that survives its explosion may stabilize, then undergo another leap, interstellar expansion, post-biological transformation, or integration into cosmic-scale intelligence. Each leap may feel like a new Cambrian, destabilizing, dangerous, transformative. The universe may thus be filled not with steady empires, but with civilizations in transition, always on the cusp of their next threshold. In this view, humanity's current moment is not the endgame, but the beginning of a larger evolutionary arc, one that could last millions of years, or collapse tomorrow. The Cambrian Explosion was a turning point for life on Earth. The Great Filter is the shadow of that turning point, projected onto the cosmos. Civilizations, like species, face explosions of complexity. Most perish. A few adapt. An even smaller fraction may transcend, joining a cycle of cosmic evolution we barely glimpse. Humanity now stands at its threshold. The silence of the stars may be warning or invitation. If the Cambrian pattern is cosmic, then our task is clear: survive the explosion, pass the filter, and join the future beyond. The Cambrian teaches us that complexity comes suddenly, brutally, and irreversibly. The universe asks whether we are prepared to carry that burden, not just for ourselves, but for intelligence as a whole. In the end, perhaps the great silence is not emptiness, but the pause between bursts. And we, standing at the edge of our own Cambrian, must decide whether we will be another brief flare in the void, or the first note of a cosmic symphony. There is a strange comfort in imagining that humanity's story is not a cliff, but a horizon. Not a sudden end, but a passage. The Cambrian Explosion teaches us of chaos, danger, and extinction, but also of survival, adaptation, and the birth of entirely new possibilities. As we look forward, into centuries and millennia we will never live to see, we can imagine the arc of our species as a restless child finally closing its eyes, carried safely into a future where the explosions have softened into light. Every great transition feels like an ending. For trilobites, the Cambrian seas were both cradle and battlefield. For us, the age of technology is both promise and peril. Nuclear arsenals, climate shifts, artificial intelligence is rising. These are waves that can drown us, or lift us higher. But history whispers that explosions do not last forever. They are thresholds, not permanent states. After turbulence comes stabilization. After fire, warmth. After chaos, structure. If humanity survives its own Cambrian, our sudden acceleration into power, we may enter a long era of maturity. Imagine AI no longer a wild force, but integrated into a balanced ecology of intelligence. Energy harvested from stars, not ripped from fragile ecosystems. Conflicts resolved not with annihilation, but with equilibrium. This is not utopia. It is simply survival carried forward until stability feels natural. Like ecosystems after mass extinction, life reorganizes, adapts, and finds new balance. To think of the future as a lullaby is strange, but apartment lullabies are songs that admit danger while offering comfort. Many ancient cradle songs speak of wolves outside, storms approaching, spirits in the dark. Yet the melody reassures, rest, because you are not alone. Our future's lullaby might sound like this. Yes, we have created tools we cannot yet control. Yes, our species trembles under the weight of its own inventions. But within every danger lies a seed of safety, and within every threat lies the possibility of wisdom. Sleep, not in ignorance, but in trust that growth is possible. In this light, the explosion is not a death sentence, but a rite of passage. The dangers are real, but so is the resilience of life. Biology reminds us, endurance is not about perfection. Dinosaurs ruled for 150 million years, yet fell. Mammals survived by being small, adaptable, and patient. Coral reefs collapse and rebuild, forests burn and regrow, species vanish and others take their place. If humanity is to endure, it will not be because we are flawless masters of technology, but because we learn how to bend, adapt, and recover. The maturity beyond our explosion will be less about control, more about harmony. Perhaps the future's humans, or post-humans, will laugh at our fears, just as we laugh at Cambrian creatures struggling to grow shells and eyes. What feels like an unbearable chaos today may someday be remembered as childhood storm, survived and surpassed. What does it mean to fall asleep in the future's light? It means to imagine that one day, humanity may no longer live in constant crisis. The fever of innovation will cool into rhythm. Exploration will extend outward, not in desperate leaps, but in steady steps. Our descendants may walk calmly among stars, not as conquerors, but as gardeners of worlds. A civilization with wisdom proportionate to its power. A humanity that no longer fears its own creations, because it has learned to integrate them. A future where the rush of explosions has settled into the glow of continuity. Like a child drifting to sleep after a day of restless play, our species may one day rest, not in extinction, but in the security of maturity. To end with faith is not naive, it is necessary. Every great threshold in history has felt insurmountable. The invention of fire could have burned us out. The creation of weapons could have ended our story long before it began. Yet each time, the arc bent toward survival, toward learning. We may fail. The Cambrian warns us that extinction is real. The Great Filter warns us that silence may be the fate of most civilizations. But possibility is not certainty. If even a few lineages survived the Cambrian to give us eyes, lungs, and thoughts, then perhaps humanity too can pass through its fire. Faith does not mean ignoring danger. It means believing that resilience is possible even when danger is real. The Cambrian explosion was a storm of life. Our technological explosion is its echo in thought and culture. Both are dangerous. Both are creative. Both are decisive moments in larger arcs. The story we tell ourselves matters. If we see our future only as apocalypse, we may give up too soon. If we see it only as utopia, we may grow careless. But if we see it as a lullaby, a mixture of fear and comfort, we may carry the paradox honestly, danger and hope, fragility and resilience, collapse and endurance. To fall asleep in the future's light is to trust that after storms, there can be mornings. To know that while explosions are fierce, they are not forever. To believe that, Like the trilobites who seeded ecosystems and the mammals who inherited Earth, humanity may yet write its chapter beyond the filter. So let us imagine, gently. The year is far beyond our lifetime. Humanity has survived its adolescence of fire. The skies are calm, stars mapped, worlds seeded. Children laugh in languages unspoken today. Machines and minds share a balance that feels natural. And when they tell stories of their origins, they will remember us not as those who failed, but as those who carried the torch through the explosion, into the calm. The future may yet hold its dangers. But like all lullabies, its final word is not fear, it is comfort. Sleep, then, humanity. Sleep in the light of futures not yet written. The explosion is loud, but the dawn beyond it is quiet. And in that quiet, life endures. Thank you for drifting with me through this journey tonight. From the ancient oceans of the Cambrian to the glowing skylines of our technological age, we've seen that every explosion, of life, of ideas, of creation, carries both wonder and risk. But now, as the stars settle above us, it's time to let go. Close your eyes, breathe deeply, and remember, even in the face of chaos, humanity has always found ways to endure, to adapt, and to dream. So rest well, dream boldly, and let the universe cradle you in its quiet light. Good night, traveler. Sleep peacefully beneath the cosmos.